All right, everybody. Today we're going to be talking about finding the angle measures using our trig functions. So, we have talked about using sine, cosine, and tangent to find different sides in our right triangle using an angle, one of the two acute angles, but we can also find the acute angle if we know two of the sides. So we use what we call the inverse trig ratios. The inverse trig ratios you may see in here. So we call these look like sine, a little -1, a cosine with a -1, and a tangent with a -1. Call those the inverse sine, inverse cosine, and inverse tangent. You notice that all of these find the angle measure. So use your inverse only to find the angle measure. Doesn't tell you anything about the sides. You use the sides and our inverses to find the angle measure. So first let's go through how do you do that. Now a lot of you might have a calculator like this. Remember, if you're here, make sure your mode is in degree mode if you're looking for degrees. So you don't want to be in radians. Change your mode to degrees. Mr. AK had to change his to degrees before we started this. And then notice that all your sine, cosine, tangent that you've used to find side lengths, the inverses are these little guys up here. So in order to use those, you're going to have to press the second button and then these buttons to use those inverses. If you do not have a graphing calculator at home, you could use Desmos. So on Desmos, the Desmos graphing calculator, you click the functions here, and they all pop up. There's sine, cosine, tangent, and these other trig functions that we don't talk about in geometry this year, or at least not right now. Don't think we do. And then the inverse right next to it. Okay. But going back to, so how am I going to find this angle A? Well, if the sine of angle A equals 0.5, you're going to plug in the inverse sine to undo that. But then you have to do the same to the other side if you're solving for the angle. So then angle A equals sine inverse of 0.5 or 0.5. So go ahead and plug that in. We've got inverse sine of 0.5, and we get A equals 30 degrees. This one's a tangent of C, so we're going to plug in the tangent, inverse tangent of 0.5773. Inverse tangent of 0.5773, and you get, well, if we round to the nearest degree, 30 again. This one would be the cosine, inverse cosine of 0.6 equals 53 to the nearest degree, or 53.13 if we were using a couple decimal places. And this one, we'd have the tangent inverse tangent of 48 over 106. And we'd get an angle of, and when I plug this in, your graphing calculator will automatically put in parentheses when you type your inverse, like inverse tangent here. And then you can just use your division symbol in parentheses as a fraction here, and you should get 24.36, or just 24 degrees. So that's what we're going to do all today. We're going to use those ratios we've been talking about to find angle measurements. So take a look at this triangle here. So angle C right here. How am I going to find angle C? Well, they gave me this side length and this side length. You need to decide what side lengths are those? Well, if this is our acute angle, this is our hypotenuse, and we don't know the hypotenuse, but we know what the adjacent is, and we know what the opposite is. So which of our trig functions uses adjacent and opposite? Think back to SOHCAHTOA, your little acronym there. That TOA uses O and A, so we're going to use the tangent. Angle C is equal to the tangent, or inverse tangent. Sorry, we're finding the angle, so we're using inverse tangent of opposite over adjacent, 15 over 8. Meaning, right, our tangent of C equals 15 over 8. So if we need to find the inverse tangent, or find the angle, we're going to use inverse tangent. Angle A over here. So angle A would also, now I'm going to erase here, because the hypotenuse stays the same, but now our opposite is 8 and our adjacent is 15. So the tangent of A equals 8 over 15. So now we plug in the inverse tangent of 8 over 15 to get the angle. So if I do that on my calculator, for the first one, I'm going to get about 62 degrees. So this is 62. And if I do the next one, I get about 28 degrees. So this is about 28, which makes sense, right? On a triangle, they add up to 180, or triangle sum conjecture. So we know that 90, 62, and 28 equals 180. Works out. You may have also noticed that this, when you're using your inverse tangent, there's a fraction, and this fraction is bigger than 1. But up here, if you go back to these examples, all of our inverse sine and inverse cosine functions are less than 1. They're all fractions. So if you were to plug in, let's say, the tangent of 106 over 48 here, or sorry, cosine of something bigger than 1, so let's plug in the inverse cosine of 2. Oops, it says error, because the inverse cosine or inverse sine of something has to be between 0, -1, and 1. Or really, you'll see it's between 0 and 1 in our triangles. So let's find this one, angle D. What did they give us for angle D? Well, the tangent of angle D, I know it's tangent because this is our opposite, and this is the adjacent, and this is the hypotenuse across from our 90-degree angle. So since we have opposite and adjacent, we're going to use tangent and get opposite over adjacent. And now we use our inverse tangent to find angle measurement. Oops. Of 107 over 128. And we get the inverse tangent of that is about 40 degrees. Now, if we had to round, hopefully you learn your rounding, right? It would be 39.89. Okay, this angle F. So we've got our adjacent down here, opposite over here, and the hypotenuse across from our 90-degree angle. So if we're trying to find angle F, we have our opposite and hypotenuse. So we're going to use the first part, sine. So the sine of F equals 36 over 66. So the inverse sine of 36 over 66 equals F, which equals 33 about. Or if you want to be more precise, we could use decimals. Now, as I said before, remember, this inverse sine is always less than 1. We've got a fraction less than 1. That makes sense. Otherwise, you'd get an error. Find the measure of each angle. So angle X. Well, we've got all three sides here, so now you can kind of use whichever one you want. Let's start with cosine. We haven't used that one yet. So we've got inverse cosine of, well, cosine of angle x over here. Cosine is adjacent over hypotenuse. Adjacent over hypotenuse. Would be the inverse cosine of 3/5. And the inverse cosine of 3/5 is about 53 degrees. Now, you may be saying, Mr. AK, now I know that z has to be 27 because it has to add up to 180. You'd be right, but I still want you to show me some way using your trig functions to get angle z. So if I plug in the inverse sine, now if I'm using angle z down there, this is no longer adjacent, this is opposite. So now I can do the inverse sine of 3/5 to get z. And, oh, sorry, 37, not 27. Did I say 27? I did. I did my math wrong. But that is 37 degrees. Mental math, end of the day. Okay, so now a 30-foot cable is used to support a 250-foot radio tower. What angle is created between the cable and the tower? So let's draw a picture. We've got a tower here. That's 250 feet. And then we've got a cable that goes from the top of the tower down to the ground that supports it and is 300 feet. And look at that. It's a word problem that's going to make a right triangle. This is our top of the tower. So the angle we're talking about is between the cable and the tower right here. So I can see that we have the hypotenuse and the adjacent. So I'm going to use inverse cosine because that's the one that uses adjacent over hypotenuse. So the angle created, in your calculator, punch it in, is 33.56 if we're going to round to the nearest hundredth. So 33.56 degrees. Ta-da! And that's it. If you have any questions, please send us emails. We can set up video chats, all that kind of stuff. Just remember that your inverse trig functions are used to find the angle measurement. Don't mess that up. Okay. Have a great weekend after you finish your classwork tomorrow and, well, Friday.